Today's video is solving quadratic equations. Really, it's only one additional step that we have to do to solve a quadratic equation. The goal will be to review factoring. I'm going to go over some things that I noticed you were having difficulty on in your homework assignments. I also want to remind you that when you turn in a homework assignment, make sure you're uploading a clear picture because I'm writing feedback on it. That feedback is supposed to help you, and you'll see a private comment saying see feedback. I noticed that a lot of people made a certain mistake on factoring worksheet number 1, which is where you have to pull a negative GCF. And I wrote some feedback, but again, people made the same mistake on worksheet number 2, which leads me to believe that not everyone's been checking the feedback that I've been writing. So please, 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 if I write some feedback for you, go ahead and check that out. All right, let's start with example number 1. Oh, actually, before I do that, see the directions. It says find the zeros, roots, x-intercepts of the following quadratic equations. The solution we find when we put x equals some number, that number, or those numbers, because there could be more than one, represent the x-intercepts on the graph. And we call the x-intercepts our zeros or our roots as well. So this is just some terminology that you'll hear me discussing. All right, example 1. I have a trinomial where a is equal to 1. I want to remind you, whenever we're factoring, I need to check for a GCF. When I looked at this, I saw there was no GCF other than 1. So I don't have to pull anything out. When you have a trinomial where a equals 1, you can use the guess and check method. You could also use the box method, that's fine. I just think that this is a little bit faster, so that's what I'm going to do. Remember, for guess and check, you ask yourself what are the factors of the constant. So I have a -4. Those factors would be 1 and 4, 2 and 2. That negative tells me I have to use different signs to get the middle term of -3. Well, if I want a -3, I can make a 4 negative, a 1 positive. The factored form is x plus 1, x minus 4, which is set equal to 0. So we haven't seen it written as an equation before. This is an extra step. If I want to find the zeros or the roots or the x-intercepts, all I have to do is set each set of parentheses equal to 0. If there were a GCF, we would also set that equal to 0. You'll see that a little later, though. X plus 1 equals 0, x minus 4 equals 0, and now we just solve for x. Here, to get x by itself, I subtract 1 from each side, so I have x equals -1. And here, to get x by itself, I have to add 4 to each side, so x equals 4. Meaning I have 2 solutions, or 2 x-intercepts, if I were to graph this. All right, example 2. Once again, we have a trinomial where a is equal to 1. There's no GCF other than 1. If you want to write that, you can. Maybe you would notice something else as well. K squared and 144 are perfect squares of k and 12. So I'm just going to check and see if this is a perfect square trinomial. Remember, it's a squared, b squared, and 2 times a times b. So 2 times k times 12 is in fact 24. So yes, this is a perfect square trinomial, which means it's either going to be k plus 12 squared or k minus 12 squared. Well, because it's plus plus, I know it's k plus 12. You can go back in your notes and see what was I going to say? Oh, you can go back in your notes and see what the exact rules are. If you don't want to have it memorized, that's fine. Guess and check method would have also worked here. If you list out of the factors of 144 and ask yourself what would add to give you 24, it would be 12 and 12. And then k plus 12 times k plus 12 is k plus 12 squared. All right, now I need to solve for k. To undo this square, I'm going to take the square root of each side. That essentially cancels out my square. So I have k plus 12 equals, technically when I take the square root, there should be a plus or minus. We'll talk about that later. But because it's the square root of 0, it doesn't matter because 0 is neutral. And then to get k by itself, I subtract 12 from each side, meaning that I have one solution of negative 12. Example 3. First, I need to check for GCF. There is no GCF other than 1 here between my terms. Now this time, A is not equal to 1. And when that happens, I had you do the box method. I saw some of you did the diamond method or factoring by grouping. Whatever is fine. If box method doesn't help, it doesn't help. As long as you find your own solution process by looking online, that's okay. I will say though, there's a lot of methods out there, so when I'm grading, the only one I can really give you feedback on is the box method, because that's what I'm familiar with, and that's what I'll be using. Alright, so for box method, you have to draw your box. Your first term goes in your first box, last term goes in your last box. Then you need to multiply these together. That gives me 30x squared. If I list out the factors of 30, I have 1x, 30x, 2x, 15x, 3x, and 10x. Because this is positive, I need to use same signs to get the middle term of negative 13x. So when I'm looking at this, using different signs, I could get negative 13 here, but I don't want different signs, I want same signs, so I'd have to use the 10 and the 3, making them both negative. Now I'm going to star this because a lot of you got a problem like this incorrect on the homework. You didn't pay attention that we had to use, in that problem, different signs. Okay, so be careful. If it's a positive, use same signs. If it's a negative, you must use different signs. It doesn't matter if I put the negative 3x here or the negative 10x here, we're going to get the same answer. Now, you need to pull out the GCF for each pair. The GCF here would be a negative 3 because both terms are divisible by 3 and there's a negative on the outermost box. The GCF here will be a positive 5x because both terms have an x, both terms are divisible by 5, and there's an outermost positive box. All right, here the GCF would be a positive 1x because they both contain x, no GCF other than 1 for the numbers, and there's a positive outermost box. And the GCF here would be a negative 2. Both terms are divisible by 2, and there's a negative on the outermost box. That means that my final answer is going to be 5x minus 3, plus 5x minus 3, x minus 2, and we have to set that equal to 0 because now we're solving. So we're not just factoring, we're taking it one step further. I have to set each parenthesis equal to 0, so 5x minus 3 equals 0 would give me one solution, and x minus 2 equals 0 would give me the other solution. Then you just solve for x. Here I would have to add 3 first, give me 5x equals 3, and then I'd have to divide by 5 to get x by itself, so x equals a positive 3/5 for one of my solutions. And then for the second one, I just have to add 2 to each side, giving me x equals 2. Example 4. Now I have a binomial. Whenever you have a binomial, you want to check for first a GCF, as usual, and then second, see if it's a perfect square. Remember, there's a rule for difference of 2 squares. Again, you can look back at your notes to find that specific rule if you'd like. I need to ask myself what squared would give me 81n squared minus and what squared would give me 16. Well, 9 squared would give me 81 and n squared would give me n squared. 4 squared would give me 16. So that's my A and that's my B. If I use the difference of 2 squares, that means I can write it as 9n plus 4 times 9n minus 4 equals 0. Set each parenthesis equal to 0 and solve. I add 4 or subtract 4, divide by 9, I get negative 4 ninths. Add 4, divide by 9, I get positive 4 ninths. So a negative and a positive 4 ninths would be my solution. All right, example 5, I want you to star this one because a lot of people miss this on worksheet number 1 and number 2. When we're factoring, we would like to have our first term be positive, all right? If this is not the case, you need to pull out a negative GCF. In this case, my GCF, like I said, is going to be negative because I want to make my first term be positive, and each one is divisible by 3, so a negative 3. When I pull out a negative 3, remember you divide each term by the GCF, that negative is going to change all of these signs. So it would be a positive b squared minus b minus 30. Setting that equal to 0 because we're solving now. What's inside of the parentheses is what we're going to factor now. Now, inside of the parentheses, we have a equals 1, so I'm going to use the guess and check. You can list out all the factors of 30, or when I look at this, I immediately think of 5 and 6 because I know using different signs, I can get a negative 1, making the negative 6 and the positive 5. So I get negative 3 times b plus 5 times b minus 6. Now we set each term equal to 0. That includes the GCF. So I have negative 3 equals 0, b plus 5 equals 0, b minus 6 equals 0. Sometimes the GCF will give you a solution if there's an x to solve for. However, in this case, negative 3 will never equal 0, so this GCF does not give me a solution here. Here I can subtract 5, giving me a negative 5, and I can add 6 to give me a positive 6. So I have two solutions of negative 5 and positive 6. Example 6, when I look at this, I see that it's different than the other examples because in all the other ones, they were already set equal to 0. This one isn't. So I need to get everything over to one side of the equation and set it equal to 0. So I'm going to say first step is to set equal to 0. You want to move everything over to the side that will make the first term, the term with the x squared, be positive. So I'm going to keep this here. I'm going to subtract the 8x and add the 1 over to the other side. So 16x squared minus 8x plus 1 equals 0. And I am almost out of time for this video, so what I'm going to do is I'm going to stop it here, and part 2 I'll pick up with this problem.